Okay, so we're gonna get started today. Okay, so we don't have everyone yet, but you know, I guess they'll see the message. But if you guys haven't seen, well, yeah, all of you already saw the message probably. If you open up a MATLAB and you weren't here watching Osseo, you're probably gonna see that it says that your MATLAB license basically is gonna expire in 14 days. So Osseo has a PDF in the group chat if you want to look at that. But if you want to reactivate it, also we go to help, right? Help and then licensing and activate software.
Yep.
Okay. So yeah, you go there and then just go through those steps there, or you can look at the PDF too for, I guess, kind of in detail steps. So it's kind of weird that they already have this, that our license is expiring already, because it's usually like a full year when we have it. So this is pretty soon. I don't know why. So anyways, yeah, just do that and then you can get it reactivated and then you're going to be fine. But again, yeah, it's kind of weird. It's already expiring. So, okay, yeah. So also will send it again. I'll also, can you also put the PDF in the Discord too?
Yeah.
Okay, thanks. Okay, so, hopefully all of you turned in your project because that was due last Wednesday. And, I haven't started grading them yet. I'll probably start grading them this weekend when I have some time. And I know you guys are going to want to get your grade on that, fast because we haven't really done too much in terms of grades for this class so far. It's just been quizzes and homework so far. So I know the projects are kind of the meat of your grade and the quizzes, I guess. But I'm gonna try to get those graded as soon as I can without obviously rushing. But I'll do that starting this weekend, and then your second project that'll either be assigned this Wednesday or sometime this weekend. And then you're gonna have I think it's at least 3 weeks to work on that. I'm probably gonna have it due after finals, because if you want to study for your finals at the very end, you can do that too. I mean, Amro, do you want it after break? You're gonna have less time then. It's up to you when you want to start working on it, but yeah. So I'm gonna assign the project either this Wednesday or before the weekend. Um, so I'll talk about that either again this Wednesday or in a video after Wednesday, but basically whether I don't know if you're gonna like it or not, but it's gonna be basically the same project, but you're gonna be doing it with for looping instead. So it's gonna be a lot more efficient, but we're gonna have to do looping instead of kind of typing out a lot of the stuff by yourself. And for that, I'll actually basically have a handout that shows you, I guess more specifically what I want to see. So how I kind of want to have you have the loops constructed. So I'll give you kind of a skeleton and you're going to have to fill it in for looping. It'll make more sense once I actually give you the handout. Okay, so yeah, that's the plan. And your second project, it's worth more than your first project. So, you know what you should get now because you already did the first project. And I'll also probably make a video for my code for the first project so you can get an idea of maybe how to write some of your code a little more efficiently. Okay, there's a question. Do we have if for the project? So I think you mean if conditionals. No, I don't think you need that at all. I didn't use it for my code. So I'm not going to require that. I don't think there's actually any case when you would need that anyways. So yeah, the main focus for the project is going to be on for looping. Okay. So if you have more questions, we'll talk about it a bit more on Wednesday, and then of course after that, the break is going to start. So you can either go in the Discord or email me, or you can wait till after break. Okay, so that's the plan. Oh yeah, and then we're gonna have a quiz this Wednesday as well, so we can start having so we can have more quizzes because I know we don't have too much quizzes yet. It's gonna be one question. It's gonna be on for looping. Okay, any questions before we get started? Okay, so last time we were going through a kind of a practical looping example. So we're actually going to go through this again because we were going kind of fast last time. And, again, our project is going to focus on for looping. So I think it'll be a good idea to kind of, we're actually going to start from the beginning to kind of reiterate some of the stuff and also just go slower so you can hopefully understand it a bit better. Okay, Victor, no, the homework is going to be assigned on Wednesday. So I know we have a quiz on Wednesday, but for studying for the quiz, just go through the slides, and what we go over today will help you out as well. The homework is going to help you with the for looping, while looping, and then also really it's going to help you for the project. Okay, so yeah, we're going to go through this example again to kind of, again, reiterate some of the techniques for looping and also help you for the quiz and then for the project. And then after that, we're going to go over while loops, and then we're going to go over some debugging. So we're not going to go over while loops in too much depth. We're just going to go over one or two examples, and then we're going to go into debugging. So while loops are good, but they're not used really too often because we usually know the length of whatever data that we have. So it's more of, I think it's more theoretical, really. It's not used all too much in practice, but it's still something that's good to know. So we're going to go over that too. Okay, so we're going to go over our example here. So what we're going to do is for looping, and we're going to make this plot in the end. So this data, it's on Canvas, so you should have downloaded it last time, but if you didn't, it's on Canvas. You can go to week 13, and then it's called Holy Trout Data. So get that. All right. So we're gonna make this plot here. So basically, it's just data for Mike Trout for his career. We're gonna plot the amount of singles per year, doubles per year, triples per year, and home runs per year. All right. Okay, so the first thing, as usual, let's make a little comment up top here. Mike Trout example. And we're going to clear the memory. I had it backwards in my slides here. But we're going to do clear, and then we're going to do CLC. Okay, and then I'm going to actually, what I'll do, and this will make sense later on once we actually go over debugging, I'm going to make a section here. Okay. So here we're going to import our data. Okay, so we're going to do trout equals read table. So we're going to use a read table function so we can import our data. And we're going to type in holy_trout.csv. Right, that's what our file is called. And then I'll put a semicolon to suppress the output. Okay, so if I run this right now, and we go over here to open up our table, we see our table here. It's a really big table. We have 23,000 rows and 89 columns. So basically, it goes over every single pitch that Mike Trout saw in his entire career. Ton of stuff. Okay, so right now we see that we start out at the very top here for 2020. And once we go down, it's going to show us some different years. It's going to take a bit to load. So now we're in 2015. So what we have to do is separate all of this, or what we're going to do. You could actually just access everything directly from this table, but for the sake of our exercise here, for looping, we're going to separate all of the years into their own table. Okay, so the next thing that we're going to do, we're actually going to do this here. We're going to do trout.player_name equals string, and then trout.player_name. So if I open up our table called Trout, and then I go to player name, which is on column 6, you see it's not a string yet. I think it's a cell array right now. I'll need to check again, but you see we only have single quotes here, so it's not a string. So if I was going to access this old Mike Trout's name, it wanted basically if I was going to call on it, it would just call on individual letters and not this entire 2 words here. So we're going to convert the rows in column 6 here to a string. We're going to do that just so we can access it as a string later on for our title for the graph. Okay, so we do trout.playerName. We're using this dot because we're accessing a table, so we have to do dot indexing. So we're going to do trout.playerName. Player name, again, that's the column. And then we're going to convert it to a string. So we're going to use our string function here. Okay, so now if I run this and I type in class trout.playerName, this will show us the type of variable or the type of data that we have for that column. Oops. Trout.playerName I should have done. And then we see that it's a string. Okay. Okay, so now we're going to separate everything by the year. So we've gone over, the beginning, the first part of this last time. But so I'll go over the first parts, a little fast. So let's separate data by year. And the first thing we'll do is we're going to make a date vector. So to do this, we're going to use a function called dateVec. So I'm first going to assign a variable here called date_vec equals dateVec. That's our function. Then we're going to do trout.game_date. Now if I run this, and I open up our variable that we just created called date_vec, you'll see that our dateVec function was applied. So this function basically breaks up a date into different columns. So we have a column just for the year, we have a column for the month, a column for the day, and then we have it by hour, minute, and seconds. Of course, we don't have hour, minute, and seconds here, so we're just going to have the year, the month, and the day. So I'm doing this so we can look at just the first column here for the year, and then later we can separate or find all of the unique years that Trout played. Okay, so this is an easier way to just look at the year and not have to deal with everything else too. Okay, so now we're actually going to find the unique years that he played. So here we're going to use our unique function that we learned, I don't know, a few classes ago. So we're going to type in years. This will be our variable. Then we're going to say equals unique. And then we're going to access our dateVec array that we just made. So we have dateVec. Then we're going to look at all of the rows in the first column. And this is going to look at, again, all of the rows in the first column here, and it's going to return the unique years that we have for this array. So we have 2011 to 2020. Okay. Okay, so now we're going to start looping. So this is the kind of the meat of the code here and what you're going to really need to understand for the project. So looping is great, and you're going to use looping quite a lot for, really for everything. I use looping all the time. I'm using it for my you have to use it sometimes. It's just not practical to go kind of line by yourself, right? So for one of my classes that I'm taking, we're using MATLAB for that, and we have to use looping for that. So and then for the labs that you're going to take, 306A and 306B, and the other labs too, if you haven't taken those yet, you're going to be using MATLAB, or you should use MATLAB. It'll make it easier on you, and you're going to be using looping for that too. So looping is really good, but you need to make sure that you actually understand what you're really trying to achieve. Okay, so we'll make a section here called gather specific data. And then we're going to start our loop here. So we're going to do for j. J is going to be our counter. So for j equals 1 to the length of years. Okay, so I have for j equals 1 to the length of years. So basically, this is going to have a pass in our loop for each year. So we're going to get data that corresponds to the year 2011. Then we're going to go on in our next pass and get data that corresponds to 2012. Go on another pass, do it for 2013, and so on. Okay, and then why did I just type length of years and not actually just look myself and go, okay, the length for years, why didn't you run? The length for years was 10, so why, some of you might be thinking we can just do for j equals 1 to 10, which we can, but then we're kind of hard coding, so if this data was going to change, then we would have to change this limit as well. So we can keep it general to just be the length of the years. Okay, and you should always try to use coding like this. So you don't actually have to go in and change a lot of things yourself. It'll change automatically for you if this data for our table is going to change to, let's say we want to run the script again for next year, right? I won't have to change anything in the script because I have this kind of formatting here where it's just going to look at the length of the years that Trout played. Okay, so just keep that in mind. You're going to be doing that. Well, you should be doing this for your project as well. And you already saw that too, of course, for the first project, for having your limits for when your testing day started and then when it ended. So the last testing day on the project, that was, of course, continually updating. So you should have used some kind of, well, I guess, idea like this here. Okay. So the first thing we're going to find the indices for each unique year. So if we go to our table, again, we have a ton of stuff here, and I want to make logical sense to go in and look at this manually to find the index for all of these years. So if I want to do it for 2020, see it's taken forever to find the last part. Here it is. So, we could go manually and go, okay, it's from row 1 to row 1023. We could do that, but that would take forever. So we're not going to do that. We're going to use looping, and we're also going to use our friend is member, which I don't know, maybe you guys hate that now, but it's very useful, right? So we're going to use looping so we can actually get the indexing for each year, and then we're going to use find and is member to actually find the corresponding indices for each year. Okay. So we have 4j equals 1 to the length of years, and then we're going to find the indices for each unique year. So I'm going to make a comment for myself. Find indices for each unique year. And of course, it's good to always type out comments. So, if you're going back to your script later on, you can actually know what you're doing for each line of code. And then also, really, just for me when I'm grading your projects, it's going to be a lot easier for me to understand what you're trying to do. Okay, so the first thing we have unique year indices, and then we're going to specify I want to get all of the rows for those indices, and then I want to do it for the jth year. So if we go through our first pass, it's going to do it for j equals 1, so that'll be for the year 2011. And then it'll do, in our second pass, it'll do for j equals 2, which is going to be 2012. And then we're going to be able to get the indices for each unique year. And then we have the curly brackets here, or the curly braces, because we're going to make a cell array. So I'll show you that after we finish typing this out. Okay, so now to actually find those indices, we're going to do find. That'll give us the actual index. Then we're going to use isMember. We're going to type in the datefec array that we made that shows the date for every single pitch that was shown to Trout. So this is the same length as our table. So really this was just accessing just this column in our table and then breaking it up into a date vac. Okay. And then we're going to put a comma, here's J, and this will, again, go through each unique year that we have. Okay, and then we're going to end the for loop. And then now if we run this, then we see in our workspace that we have something new here. It says it's a 1 by 10 cell. So if I click on that, then we see that we have a cell array. So if I double click on one of these, then I can open them. I can open it and then I can see all of the indices that corresponds to some year. So this is actually for the year 2011 here. So if we go back to Trout and we go to row 22,956, I know we did this last time, but let's refresh ourselves. So, oh boy, I gotta go down a lot. So we're just gonna verify that this actually worked correctly. So 22,000, and I already forgot it, 956.
Would it be okay if we pre-allocated memory for the unique year and unique year table vectors?
Yeah, we're actually gonna go over that later in this lecture today too. But yeah, you should always pre-allocate your memory if you can. Okay, so if we go there, then we see that this is the first index for the year 2011. So that worked out. As you see here, we first have a warning that says that our size is changing in each loop, so we should pre-allocate for speed. So just like Ryan just talked about, we're going to do that, and it's a good idea to do that. But we're actually going to go over that a bit later today in this lecture. So as this is right now, this is still fine. It works, but we have this warning there that says that we should pre-allocate. So basically specify the size of the array before we make it. Okay, and so we talked about all of this last time, and we went over it today too. So let's just keep going here. Okay, and now we're going to make a table for each year. So we have all of the indices for each year. Oh, and we're also using a cell array because all of these are different lengths. So if I was going to make these all into just one table or array, I can't do that because they're all different lengths. So we use a cell array because they basically have their own array inside of this cell or this cell array. So here's one unique array here. Here's another unique array here, and then here, and so on. Okay, so now what we're going to do, we're going to make a table for all of our years. So far we only have the indices, but we want to use those indices to make a table that contains all of the data for each year. So we're going to do unique year table, and then we want to do it for each year, so we're going to use a curly bracket and specify J. And then Trout, so now we're using array addressing, so we're going to access our our main table, Trout, unique year, int for indices. We want to get all of the rows for each year, and then I'm also going to put another comma and then a colon, because I want to get all of the columns in our main table that's called Trout. Now if I run this and then I look at our table, well, this is a cell array that contains tables for each year. Then I see that I have all of the data here for 2011, all the data for 2012, and so on. Okay, so we're looking good so far. Okay, now we actually want to find the amount of times that Trout had a single, a double, a triple, and a home run. So we're still in our for loop here, and we want to do this for each year. So that's why we are going to specify our counter of J. So that's going to basically have a pass for the year 2011, for 2012, and so on. So that way we don't actually have to type out ourselves, singles per year 2011 on one line and then another line singles per year 2012. That would really just start to add up, kind of like you saw in your first project. So singles, not pair, singles per year. And again, we're going to iterate on J. So I don't need to have curly braces here because I don't need a cell array anymore. I can just have a regular array. Because we're just going to have a scalar in the end, because we're using our length function here, that'll basically return just a scalar, so just one number that's going to tell us the amount of singles that Trout had per year. So length, find, string compare, unique year table. We want to do this for each table that we had, so we're gonna use curly braces again. All of the rows for the jth year, and then dot events. So we're using dot notation to look at the actual events, and that'll basically say what happened. And then I want to type in single. This is for our string compare again. So this is a long line of code, I know, but basically dot events in our main table here. That's column 9, and that just tells us what happened. Okay, so we want to find one that says a single. So like right here on row 173, there is a single. Okay, so now if I run this and then I look at singles per year, now you see that we just have, again, a scalar for each year. So in the year 2011, he had 16 singles. In 2012, 117, and then we go on and on. Okay, so we're going to do the same thing now, but we're going to be doing it for our other kind of, results. So I'm going to paste this 3 times. And then we're going to change this to doubles, triples, and then home runs. Okay. And then we're going to change this last part over here to also reflect doubles, triples. Actually, here it should be single, double, triple, and then home run. Home run. Okay. Now if I run our code, then we can look at all of these. So this is triples per year. So you had 0, 2011, 8 in 2012, and again on and on. Okay, so this isn't too much coding here, but it saved us a lot of time because we were using looping. So we could loop through each year and not have to type it all out again ourselves. All right, let's see what we have now. Okay, so that's it for, I think that's all we have for looping in this example here. So are there any questions on the looping that we have here? Okay. Okay, so now we're going to make a table for all of the events that we have, and we're going to do it per year. So I want to have a table for each year that'll just actually show the singles for that year, the doubles for that year, and the triples and the home runs for that year. Okay. All right, yeah, just making sure that I was done with the loop. So we're going to go down below, and let's make a new section here. So we're going to make a table for chosen events per year. Okay, so I'm going to call this table stats per year. And we're going to use our table function that'll make a table for us. And we're going to do singles per year, so that'll access the array that we made. So singles per year. And currently it's a row vector, so I'm going to transpose it so it can be a column vector. And I'm transposing it to a column vector because that's how our tables are formatted. So if we go to our main table, all of these are column vectors. Then up top, we have the corresponding variable name for that vector. Okay, so that's why I'm transposing it from a row vector to a column vector. So singles per year, doubles per year. I'm going to transpose that. And then we have triples per year. Get that out of the way. Triples per year. My keyboard is a little to the left. I can't type. Okay. And then home runs per year. And we're going to transpose that as well. And then we'll close it out. We're also going to add in years as well. So remember we made this array before that just showed each unique year. And that was already a column vector, so we don't have to transpose that. Okay, if I run that and then I look at our table that we just made, here it is. So we have our singles per year, doubles per year, triples per year, home runs per year, and then the actual years. So we need to rename these first four variable names here, so we know what we're looking at. I know the first one is singles per year because that's what we specified in our line of code here. Okay, so we're just going to rename that. I guess I didn't put that in our slides here. That's okay. So we're going to do stats per year dot properties dot variable names, and then we're going to do singles. I'll just type in singles. Then we have doubles, and then we have triples, and then we have home runs. And let's see if this works like this. I don't know if I'm going to have to specify every single variable name or not. Yeah, I do. So I also need to add on years. Even though that was already there before, I need to specify that again. So now if I run our code, then that works, and I'll open up our table, and then we have all of our variable names up here. Oops, I just closed out of my slides. Okay, there we go. Okay, so now we can plot. All right. So any questions so far? Just make sure if you have any questions for the looping, obviously you want to make sure that you understand that. Okay. All right. So for our plot here, this will basically actually kind of do an implicit loop where we're going to access everything in our table that we made. So it's going to do an implicit loop. So it's going to plot, all of our singles per year, for 2011, 2012, 2013, and so on. And it's going to do that for every single kind of stat that we have here. So I don't need to explicitly define a loop. MATLAB is going to do that implicitly. Okay, so let's do another section here, and we'll call this plot. I'm going to do this part quick because this obviously isn't the anything new here. So position. This might be a little new to you. Here I'm just specifying the size of the figure that I want. So it's going to be 1000 by 500. And then I can also do something that's convenient for your scripts. I can type in these commands, visible and then off. Then when I run my code, the plot won't show up, but I don't need to comment everything out. So it'll still kind of make the plot, but it's not going to show up. Just that can be kind of annoying. Okay, and then we're going to do bar, and I have to convert this to an array to actually plot this. So I'm going to do table to array. And then we're going to do stats per year. And we want to plot all of the values that we have, so all of the rows. Then I'm going to do 1 to 4 here. Because I only want to plot the stats. I don't want to plot the years here. So I'm just going to plot columns 1, 2, 3, and 4. Okay. So if I run this now, of course, so I just ran my code, but it didn't show up because I have this command visible off. Okay, so I'm going to change this to on. and our plot shows up. Alright, so there it is. Cool. Let's finish this out really quick. Let's open to X, tick labels, and then years. So I'm specifying, or I'm calling on the array that we made that was called years. AX equals GCA, that means get current axis. AX.Y grid. So this will give us a grid. Along the y-axis, we're going to turn that on. And then we're going to put in our legend. Of course, I'm not going to actually type anything out. Myself, I'm going to have MATLAB call on these stats by itself. So stats per year, that's our table, and then dot properties, dot variable names. And we want to get the first four. So singles per year, doubles per year, triples per year, home runs per year. And we're going to take off the box around the legend. And then we'll do title. Stats for. So again, I'm not actually going to type out Mike Trout. Of course, for this table, it's so simple, or this plot, it's so simple that I could type out Mike Trout. But if we were making a table, let's say for every single player in the league, you don't want to type all that out. So you want to have MATLAB calling that by itself. So we're going to do num to string. That means number to string. Now, obviously, Mike Trout, that's not a number, that is a string. But to actually get this to show up correctly, we have to use that function. So trout.playerName. And then we can just say, choose the first one. Of course, trout.playerName, all of that was just Mike Trout. So we can just choose anyone. Okay, and then we have over his career. So you'll also notice that I have a space at the end here and then a space at the beginning here. And that'll basically make our formatting look correct in our title here. If I didn't have the space, then this would be kind of smashed against the mic. And over here, this would be smashed against the T for Trout. Okay, so there is our plot. So that worked out pretty well for us. We used looping, so we didn't have to have, 100 lines of code or something by going year by year ourselves. We had MATLAB loop through each year for us. So, any questions on that before we get started on while loops?
Quick question. What else did you label in the states per year? Because it only cuts off at years when I was looking at this. Well, what?
There, you can see them all now. Was it stats per year properties variable names? I have.
Yeah.
Okay. Yeah, I'll go over it again. Okay, Ryan, did you have a question?
Yeah, I was just trying to find an error, but I think that revealing the rest of the stats per year line helped me out.
Okay, so you got it?
Mostly, yeah.
Okay, if you still have an error, then you can stay after class too. Alright, so there we go. So now that we have that, we're gonna start our while loops today. Okay, so while loops. So I'm gonna make this full screen now. Okay, so while loops, we're gonna use these when we don't know the number of passes ahead of time. So for a for loop, we're gonna use a for loop when we actually know the amount of passes that we need to make. So let's actually go back to our exercise here. Here, I knew the length that I wanted to make all of these arrays here. So I knew that I was going to have a length of years because I had, 10 years. And here it's going to give us the amount of singles per year. So I knew the amount or the length ahead of time that I wanted to use. So because of that, I used a for loop. But sometimes you might not know the length of what you're looping on ahead of time. So in that case, we're going to use a while loop, and the loop will continue going until some condition is satisfied. So when that condition is satisfied, then the looping is going to stop. Okay. So the format for our while loop is going to be while some logical expression. Okay, so take note, it's a logical expression. We're going to go over an example here. So while logical expression, then statement, so then it's going to do something, and then we're going to end it. So what this is doing kind of behind the scenes, MATLAB's going to test the truth of our logical expression. I say truth here because, again, it's a logical expression. It's either going to be true or false. Okay, so we have a loop variable that's going to be present in this logical expression. So in this case, we have our loop variable that's going to be x. So here's an example. So we have while x is less than 25. So if that is true, then statements are going to be executed. Okay, and we're going to have an example, of course, but if some number is less than 25, then we're going to do something. Until that is, in this case, until x is either greater than or equal to 25, then once that is achieved, then our loop is going to stop. Okay, so some rules that we have here. The loop variable that we have must be defined before the while line. So what I mean there, we have our loop variable x here. I would have had to define some value for x before this line. So, and that'll kind of kickstart our while loop. So I could have had like x equals 2, x equals 1, it can be whatever. Okay, the loop variable must be acted on by the statements. So of course we need to have some statements here. And also in our statements, we need to have our loop variable present as well. And then our while statements, of course, they need to have an accompanying end statement. So we have while, logical expression, do some stuff, and then end. All right, let's show a really simple example here. So I'm gonna make a new script. Actually, I made a file for it today. Here it is. Oh, I put that in there, huh? Okay, I guess I'll make a new one. Okay, here's a new script. Okay, let's do, I'll call this class examples 11, 16. Yep. Okay. So let's clear the memory. And then we're going to have our first example here. So while loop example 1. Okay, so the first thing I'm going to do is say x equals 1. So like I said before, we need to first define our looping variable before we can actually start our loop. So I'm going to do x equals 1. And then I'm actually going to unsuppress this. So below this, I'm going to say while x is less than 10. Okay, so that is our logical expression, x less than 10. Now I'm going to put in our statements. X equals x plus 1, and then we'll end it. Okay, so what are we doing here? We have while x is less than 10, x equals x plus 1. Okay, so first off, MATLAB is going to go, okay, what's x? We defined x equals 1 up here. So, is 1 less than 10? Yes, that's true. So then our statements are going to be acted on. So now x is going to be x equals 1 plus 1. So we're going to have x equals 2. Okay, now we just finished one loop, or one pass. So now we're going to go on our second pass. MATLAB is going to say, hey, is x less than 10? In this case, it's going to ask, is 2 less than 10? Yes, that's true. So x is then going to be updated to x equals 2 plus 1 is 3. And we're going to keep on looping like that. So if I run this code, okay, so if I run this code and we look at our command window here, we can see everything that happens. So the first thing that we have is x equals 1, because again, that's what we defined in the beginning. So we have x equals 1, and then our loop starts. So we go, is 1 less than 10? Yes, that's true. So we start to do our statements here. X is then updated to x equals 1 plus 1, which is x equals 2. Okay, and then we go on our second pass. Is 2 less than 10? Yes, that's true. So now we're going to do our statements. X equals 2 plus 1, that's 3. So we continue on, and you can see that we increase in our value by 1 for each pass. So this occurs up to when we get to x equals 10. So once x is equal to 10, we go to the top of our loop here. We're on a new pass, and we say is x less than 10? So is 10 less than 10? No. So then our loop is going to end. So it's going to stop right there. Okay, so are there any questions on that?
If we were to use less than or equal to 10, would it still count 10 and make that 11? Go all the way to x equal 11?
Yeah, exactly. So let's actually show that right now. And yeah, you see we have x equals 11. So for that, yeah, we are going on our pass again. And MATLAB goes is 10 less than or equal to 10? In this case, yes. So then we carry out the statements again, and then we get x equals 10 plus 1, which is 11. And then, yeah, you can see that down here in the command window. Okay, so pretty simple. Let's do one more. Okay, so we're gonna talk about the danger zone now. So you need to be careful when you construct your while loops, because you could encounter a situation where you're going to create an infinite loop. So remember, our loop is only going to stop if some condition is met. If that condition is never met, it's going to keep on looping forever and ever and ever. So we want to be careful. If that happens, though, we can press Control C on our keyboard to kind of force terminate it. So I'll show you what this looks like right now. So, danger zone. Let's do x equals 3. So this is when I'm going to start our loop at. So we have x equals 3. And then I'm going to do while x is not equal to 0. So to do not equal to, we do a tilde and then the equal sign. So while x is not equal to 0, x equals x minus 2. Then I'll end it. So on our first pass, we're going to say is 3 not equal to 0. That's true. So then we're going to carry out our statements here. So x is going to be updated to x equals 3 minus 2. That's going to be 1. So now we're going to go on our next pass. Is 1 not equal to 0? That's true. So we're going to carry out our statement. So we have x equals 1 minus 2. So we have negative 1. And you'll see we passed this, we passed 0 now. So, of course, as we keep looping here, as we keep going through our passes, we're gonna, we're never gonna go to 0. So because of that, we're gonna have an infinite loop. So I'll show you what this looks like. Okay, so let's run this, and then you're gonna watch my command window. It's gonna go insane. And see, it's just going and going and going and going. Now this is a pretty simple loop, so you should be fine. But if any of your computers freak out, then don't blame me. If you're trying this, but it's just gonna keep going and going and going. So if I want to stop this, I'm gonna press Control C at the same time. We have to click in our command window though. Make sure you do that. And then I hit Control C and then it stopped. Okay. So that's just something that you want to look out for. You need to be kind of cognizant of what you're doing for your while loop to make sure that it's not going to be an infinite loop.
Professor, sorry, but why do we use the tilde again?
Yeah, so the tilde, that means not. So here I was checking a statement for while x is not equal to 0.
Okay, so it would go everything from -1 all the way until infinity.
Yeah. Mm-hmm.
Okay.
All right, so that's it for the while loops. I know that was like really quick, but our focus is really on for loops. That's how we spend time on that. And the while loops, again, they're useful, but they're not really used too often, at least for our field. So we're not going to go over while loops too much. I don't think I've ever actually even used a while loop in practice. Because again, we have data that we're using, and we already know the length of that data. So we don't need a while loop, we just need a for loop. Okay, so earlier in the semester, I had a question on debugging for when we were going to go over that. So I think that was like back in arrays or something. I don't know. But we're going to go over debugging now. So this will be useful as well, hopefully. So far we've just gone over debugging that in kind of a very basic sense, which is just seeing an error message in our command window. But MATLAB does offer us some more kind of tools that we can use to debug our script. So the first thing I'm going to do is I'm actually going to go back to our exercise that we just worked on today. Where did I put that? Here? Yeah, okay. So I'm going to change our plot to visible off just so I don't see the plot come up. Okay, so I'm just back to our example that we worked on in the beginning. So the first thing I'll do is change .csv to just .cs. So if I run this, then MATLAB is going to give us an error message in our command window. And of course, all of you should be used to seeing this kind of error message. If you ever encountered some error, you would see a message in the command window. So here, MATLAB is pretty good for errors. It tells us or gives us a pretty good idea for what might be wrong. So here it says unable to find or open holytrout.cs. And it also gives us the line for where this occurred. So in this case, that was line 8 in our script. So if I go to line 8, then we see that that's when the error happened. You might be wondering, what is this line 198? That's for the actual kind of script that is running in the background for read table. So the actual function read table, that has its own script that it's running, and it encountered an error for that script on line 198. But really, we just want to pay attention to this line down here, because that corresponds to the line in our script. Okay, so we know that that's something that you should be very familiar with. And then we also have another kind of error message or indication that you should be familiar with as well, which is squiggly lines. So here, this is an orange squiggly line, and it's a warning. It's not an error message, but if we had something that was wrong there, and MATLAB noticed that something was wrong, it would give us an indication. So sometimes it'll show up, like here, it didn't show up, but for some functions or some syntax errors, it'll show you that you forgot something. Or if I take off this semicolon, then you see we get the squiggly line on the equal sign. It's a warning just saying that we didn't terminate our statement here with a semicolon. Okay, so that's another one. And then we also have these lines on the right here. So let me see, I had an example. I don't know, I won't worry about that. I'll just do it on the fly. So let's change something here. See if that'll show up. No. Okay, so it's fine though. So on this kind of sidebar here, you see that we have these orange lines. Now, again, sometimes MATLAB will know explicitly that there's an error. So right now we have orange lines that indicates a warning for the line. So you see that we have a few warnings here. And that's just because we didn't pre-allocate our size of the array, kind of like Ryan was talking about earlier. So that's why we have all of these right there. And then you can also see we have an orange box up top here, and that says warnings found. We can click to go to the next message. So if I click on that, it'll go through every single time where we have a warning in our script. Okay, so those are useful, but they're They're not too kind of explicit. Like it'll flag when we have an error or a warning, but kind of what we want to talk about today is something that's a little more in depth, which will be helpful if you want to debug a for loop. Just kind of as an example here. Spelled the workspace wrong. Okay, so sometimes you want to go through a script line by line, or I guess I'm first doing section by section, so we'll do that first. So if we have a big script, and we want to go through it section by section. Let's say that we ran a script and there was some error. Okay, we have a question. Yeah, so, okay, so Min is asking, it says the variable appears to change size on every loop. That's because we didn't pre-allocate the size of our array beforehand. So we're going to get to that in a bit here, where I'm actually going to show you what's happening. Okay, so sometimes we want to go section by section. Let's say that we had a lot of errors in our script, and we just want to kind of take a step back and see which kind of areas in our code have an error, and we can kind of fix them systematically. So we can do that. So let's actually first clear the memory. So if I go up top here, because I used double percent signs throughout the script, we have different sections. So this is going to allow us to go section by section to see if there's an error in any section. So to do this, I'm first going to go up top here, and I'm going to click on, make sure you're in the editor tab. I'm going to click on run section. Okay, so of course here, it's just going to clear the memory. So nothing is really happening here. What I could also do is click on run in advance. So it's going to run this section, and then it'll take us to the next section. So let's do that. Okay, and then it automatically brought us to this section here. So if I just run this section, then it ran our script, but only for this section now, and it shows our workspace was updated for our table that we just read. Okay, I can click on advance up here to go to the next section. Okay, and then I can just run this section. So it's going to keep what we already ran in our workspace, but I can click run section. And then it updates again where we created an array for dateVec and an array for years. Okay, so let's go in the next section by clicking advance, and then I can just run this section as well. And of course, this was our for loop, so it's going to create all of the arrays that we made here. Okay, so this is a reasonable method, but for us, we might actually even want to be kind of more granular here and go line by line. So we can do that as well. So let's say we were in our for loop here and we want to go line by line to see what's happening, and even pass by pass. So that's really the big one there. We can break down our loop here to go and see the result for each pass that we have. And that'll kind of help us to debug our for loop if we have any issues. I have a few typos in here as well. I don't have spell check for when I write this stuff up. I should do that. I have to add something like a script for that. Okay. So let's go on here. So here we are. So we're going to do this line by line now. So we can do this. Instead of going section by section, we can go line by line. So to do this, we're going to use something called a breakpoint. So to do that, we can go to the line where we want to start analyzing our script. So here I'm on line 17 where I start my for loop. And I can go up here and I can click on breakpoints. And then I can click on set/clear. And that's going to set a breakpoint on this current line. So if I do that, then we see that a red circle appeared on the left here. Okay, so that's our breakpoint. So I can, now that I set this, I can just keep looping through this loop here, and I can go pass by pass to see what's happening. Okay, so this breakpoint is basically just a kind of a, I don't know, a marker for MATLAB that's saying, okay, I just want to stay inside of this loop. Okay, or so if you don't want to go up and click on breakpoints and then set /clear, you can also press F12, or what you can do, you can just go over here on the left and you see we have all of these little dashes here. And that kind of signifies to us where we can actually put a breakpoint ourselves. So I can go over here to the left and I can just left click and I can put a breakpoint in just like that. Okay, so what I'm going to do now, I'm going to go up here and I'm actually going to run in advance, and do it one more time. So now we're here on our loop, so we haven't actually gone through the loop yet, as you can see in the workspace. So I'm going to go kind of pass by pass here. So what I'm going to do, I'm going to go to singles per year, and I'm going to unsuppress it. So I'm going to delete our semicolon at the end. Okay, so this time, or this way, I'll be able to see the output for this variable. So what I'm going to do now is click on Run in Advance up top. Okay. And once I press that, because we had a breakpoint here, now we're kind of in this, I guess kind of like a subsystem here. Now we're actually doing something. MATLAB saw that we had a breakpoint, and then we clicked on Run in Advance, so it knows that we want to look at some code. So this some of these icons up here, they updated. So you see that we have a quit debugging icon, and then we have some new icons here for continue and step in, step out, and run to cursor. So we're not going to click on step in, step out, or run to cursor. If I click on step in, just to show you here, you see once I do that, this is actually showing us the script that's running behind the scenes for our for loop. This was for our isMember function. You can see that up top right here. So this is actually the script that runs behind the scenes for isMember. So I'm going to click step out. So we're not going to worry about that because, we don't really need to look at that. Okay, so what I'll do though is I'll continue to press step, and you'll see that we have a green arrow that shows us which line that we're currently on. So if I click step again, then we're going to go to line 21. Okay. And then I'm going to go click again, and now we're in singles per year. So remember, I deleted the semicolon at the end. So once I press step one more time, I should see something show up in our command window. So I'm going to press step, and there we go. We see singles per year is 16. So that was our first pass, right? We need to pass through 9 more times though, because we have 9 more years to go through. So I can continue to press step, and we can continue to go through our loop here. So now I'm about to calculate the singles per year for the second year, and then it updates again. So now we have singles per year is 16, and then it added for this new pass 117 for the next year. Okay, so if you're getting something that looks kind of suspect when you're running your script for your second project, you can kind of use this method here to debug your script to see what it's actually doing on each pass for whatever line of code that you're looking at. And I can continue to press step, and I can continue going for my entire loop here until until we finish here. So of course, we're looping through these other things that I don't currently care about, so I could just modify my for loop to only loop for our singles per year. But this is simple enough where I can just keep on looping here, and once it's done with the loop, it's actually gonna go out. Then you see that it just went down here and it finished kind of running through this loop here. So the quit debugging icon, that went away because we actually finished looking at that section of code. Okay, so that's a good method again to kind of go line by line or even pass by pass to look at our for loop. And what we're going to talk about now is pre-allocating the memory. So we had a few questions on that. So as you saw here, we were building our array for singles per year from the ground up. So we started out at 16, which is of course a length of 1. Our array here has only one element. And we built it up ourselves until we had a length of 10. So that's fine, but the question that Min had was she saw that there was a warning that shows. Actually, let me do this. Okay, my message kind of keeps flashing, but it says that our size is changing on each loop iteration. And so that's correct, right? We see that our size for each pass that we had, it's changing. It's increasing in size here. And because of that, MATLAB is less efficient. And that's why we have our warning here. So we can address that by pre-allocating the size for an array. And to do that, we're going to use our zeros command. Okay, so let's do this. So I'm going to just show you an example just for one line of code here. We're going to do it for singles per year. So as it currently stands, you see that we have this warning message. That's again referring to how our size is changing for each loop. So let's go up here to this line here, and we're going to initialize our array. So I'm going to make another section here and say initialize arrays. And then I'm going to specify the size of the array that we're going to have for singles per year. So if I look on our workspace, of course, we know ahead of time that that's going to be a 1 by 10 double. But I can specify the size before we actually even do the loop. So to do this, I'm going to do singles per year. That's the array that we're going to make. Equals zeros of 1. So we're going to have 1 row. And then for the amount of columns, again, I'm not going to do any hard coding here. So I'm going to type in the length of years. And this will just make it so we have the amount of columns that we have is going to be the amount of years that we have. So we're doing it on this line here because, of course, we actually need to first calculate the amount of unique years that we have. So what I'll do now, I'm going to unsuppress this. I'm going to go back up top, and we're going to do our kind of our method that we just learned. So I'm going to do run in advance at the top here. So everything is gone on in the workspace now. I'll click run in advance for the next section. Okay, and then I'm going to advance now to our section here where we initialize our array. So I didn't suppress it, so you'll see in our command window once I press run section, then we have singles per year. And why is it like that? Okay, yeah, there it is. So let's go back here. Yeah, it should show all of these here. So let's go back to the beginning and we'll do run in advance, run in advance, run in advance, and then we'll run that section. There it is. Okay. So once I run that, then we have our array here that's it's initialized to be an array that's full of zeros. Okay, so you should see that it's going to be a 1 by 10 array full of zeros. So now, once I go down to the next section, now you see that singles per year, that's no longer underlined with our kind of warning sign. Because we specified the size of the array ahead of time. So I'm going to unsuppress this again for singles per year. And now let's look at this pass by pass. Okay, so I'm going to go to the next section. Oops, I didn't know I was already in this section. Okay, let's go back. Let's go up to the top here. Run in advance, run in advance, run in advance. Okay, so now we're inside of our for loop. So let's do, let's set a breakpoint again. So I'm going to set it on line 20. And not what I wanted again. It already, so it did the whole entire loop for us. Let's go back here and we'll do, hold on, give me a sec. Let me clear that. Move this down. We'll go right here. All right, there we go. Okay, so I'm going to click step and step one more time. So now we're on singles per year. So now if I run this, we're going to see our array, we should have an array full of zeros, and on the first entry, we should see 16. Didn't it do? Why it's not showing it pass by pass? There's some issue that I'm encountering. So if we go to the slides, because we're running out of time, it should show it like this, where it's going pass by pass. So what you should see is that it's gonna first show 16 because that's our first loop that we have, or our first pass. And then because we pre-allocated the size of our array, all of the other entries should be 0. So again, we're running out of time, so I can't debug it right now, but you should see that it's 16 and the rest are 0. Then as you continue to have each new pass, then it should update. I think the second one was 117. And then we're going to keep building our array. But because we pre-allocated the size of the array, we aren't changing the size of the array for each pass. So because of that, we're going to save time or make our code more efficient. Now for this example, the array that we're making is very, very small. So the actual difference for the time, whether we initialize the array or not, is negligible. You can actually compare it, and you can see that there's essentially no difference. So if I, really quick here, if I go to here and I type tick, and then after I type in talk, not that TikTok, then you'll see that it actually shows us the elapsed time for each pass in our loop. So you can do that, and you can compare it with initializing the array and without, and you'll see that they're essentially the same in this case because our array is so small. Okay, but for bigger arrays, it actually would make a difference. All right, so I know we're out of time. Again, I would need to actually kind of debug this, but you should see what I have in the slides here, where it builds our array one by one. In our demonstration here, it was going through the full for loop. It wasn't going loop by loop. But anyways, that's all we have time for today. So I'll see you guys on a Wednesday. And remember, we have a quiz on Wednesday. I'm going to assign homework on Wednesday. So the quiz on Wednesday, it'll be one question at the end of class on for loops. Okay, so make sure you go over the slides and you study for that. All right, so I'll see you all on Wednesday.
Thank you, Professor.
I have a quick question. I have the code and everything.